In this video, let's understand the concept of heating effect of electricity. Welcome to the next video of the chapter Electricity. What happens when electricity passes through an electric iron, electric kettle, immersion heater or in an oven? Yes, you know that electric energy is converted to heat energy. We have already learnt in class 7 that whenever electricity flows through a circuit, heat is produced. The process of production of heat in a resistive circuit when current flows through it is called heating effect of electric current. Let's understand the cause for this effect of electric current. We know that in a metallic wire, there is a random motion of electrons in the wire. When a potential difference is applied across the ends of the conductor, the electron starts to flow or get accelerated from the negative terminal to the positive terminal of the battery. During this course of motion, the electrons constantly collide with each other or with the atoms or ions of the conductor. We have learned that objects in motion possess kinetic energy. So, a part of kinetic energy of the electrons are transferred to the atoms and the atoms start vibrating, which increases its energy. As a result, the temperature of the conductor rises. Let's calculate the work done by current I when it flows through a resistance R for time t. When an electric charge Q moves against the potential difference, the amount of work done is given by W is equal to Q into V. Also, we have learned that energy is the capability to do work. So, energy E is equal to work, which is again V into Q. From Ohm's law, we have V is equal to IR. So now let's substitute that V is equal to IR in the equation for energy. Here we know that energy is released in the form of heat. So H is equal to work, which is IR into Q. From the definition of current, we know that I is equal to Q by T and Q is equal to I into T. So substitute Q is equal to I into T for the equation in heat and we get H is equal to IR into I into T, which is I square RT. Substituting Q is equal to I into T in the main equation W is equal to V into Q, we get another equation for heat, that is H is equal to VIT. If you substitute I is equal to V by R, then you will get another equation, H is equal to V square T by R. From the formula H is equal to I square RT, it is clear that heat produced in a wire is directly proportional to the square of current, resistance of wire and time for which the current is passed. The formula H is equal to I square RT gives us the heat produced in joules when a current of I ampere flows in a wire of resistance R ohms for time t seconds. This is known as Joule's law of heating. According to Joule's law of heating, the heat generated in a current-carrying conductor is directly proportional to the product of square of the current in the conductor, resistance and time of flow of current. That is, H directly proportional to I square RT or H is equal to I square RT. This means that a given current will produce more heat in a high resistance wire than in a low resistance wire. Also, a given current will produce more heat if the resistances are connected in series than when they are connected in parallel. Now let's understand a few practical applications of heating effect of current. Electric bulb. In a filament bulb, when electric current passes through the tungsten filament, it becomes white hot and emits light. Metallic tungsten is used as the material to make filament because it has high melting point and high resistance, so high heat is produced when electric current passes through it. Electric fuse. A fuse wire is used for protecting the household wiring and electrical appliances. It is because fuse wire has a low melting point and high resistance. When the amount of current rises too much in the fuse wire, it gets heated up because of the high heat produced, melts, breaks and then makes the circuit open. The heating elements or coils present in iron box, water heater, toaster, etc. are made up of nichrome wires which has high resistance and it glows to red hot when electric current passes through it. Since it has high resistance, high amount of heat is produced. Okay, so now let's check your understanding level. Which material, copper or nichrome, should be used as heating element and for external wiring? Copper wire should be used for external wiring because it has low resistance and it produces less heat. The heating element in this kettle should be made up of nichrome because it has high resistance and it produces a lot of it and it serves the purpose.